Welcome to the fourth tutorial for the GenoPred pipeline, an easy-to-use, scalable software pipeline developed at King's College London, which can be used to calculate polygenic scores. In the previous videos, we've learned how to install, configure, and use the pipeline. In this video, I want to give some advice on running the pipeline on a high-performance computing cluster, often referred to as an HPC. All of this information is also available on the GenoPred website, linked in the description below. First, I want to make the brief point that you should not run the SnakeMake pipeline on the login node of an HPC. The login node is a shared access point for the HPC and is not intended for running analyses. Instead, start an interactive session on a compute node or submit the SnakeMake command as a batch job. Now let's talk about running the pipeline in parallel. As I mentioned before, GenoPred is a SnakeMake pipeline. In the previous demonstrations, we've used the J1 parameter to run the pipeline, instructing SnakeMake there is only one core available for analyses to be conducted, therefore running one step at a time and restricting steps that can use multiple cores to only use one core. However, if you have more computational resources at your disposal, SnakeMake can easily make use of them. If you have more cores available, you can simply change the J parameter to use the desired number of cores. So if I had 4 cores available, I could set J to 4. If you're working on an HPC, you can use the profile parameter to tell SnakeMake to submit analyses as batch jobs, so they are distributed across many compute nodes. Depending on the resources available on your HPC, using the profile parameter can massively reduce the time taken to run the pipeline. For this to work, you must first create a YAML file specifying how to interact with your HPC's job scheduler. I have provided an example for users using a Slurm scheduler in the example input folder called slurm.yaml. You will need to update the YAML to specify the partitions you have access to on your HPC. You can also change the jobs parameter to increase or decrease the number of processes the pipeline will run at once. For more information about using profiles in SnakeMake, check out the website and also the documentation for SnakeMake. Once you have set up a YAML for your scheduler, you can tell SnakeMake to submit jobs to the scheduler by specifying the profile parameter, instead of using the J parameter. Although running the SnakeMake command with the profile flag uses very little memory, I would still suggest running it on a compute node to avoid clogging up the login node. Finally, depending on the analyses requested and your computational resources, the pipeline could take hours to finish. If you're working remotely, this can pose issues, as if you disconnect from the server, then the SnakeMake command will stop. To avoid these connection issues, I would suggest using a terminal multiplexer, which allows users to disconnect and reconnect to a particular session. The terminal multiplexer I use is called tmux. When I first log on to the HPC, I start a tmux session. Then I start an interactive session on a compute node. And then I run my desired SnakeMake commands. There are great resources online for learning how to use tmux, and it's likely already installed on your server. Another option to avoid connection issues while running SnakeMake is to submit your SnakeMake command as a batch job. This is also a good solution. Okay, great. With these new skills of running the pipeline in parallel, your analyses can now be scaled up to large target samples and large numbers of GWAS. Check out our website and other videos for more information.